This is a review of Unit 4. Work through each problem to prepare for your test. The formulas will be available for you. You don't have to take notes on those. Practice taking relevant information and putting it into the correct formula to solve each problem. None of the problems that you see are actual problems on your exam. They're just sample problems. And don't forget to use the study set for Unit 4 in Quizlet. Let's look at question 1. What is the value of x that satisfies this equation? Log base 5 of x plus 3 equals 3. Highlight x, we're looking for x, what we're looking for, and highlight the problem log 5 x plus 3 equals 3. Set this up as an exponential equation. Use your hamburger helper hand method. So we're going to put log base 5 x plus 3 equal 3 into the hand, starting with 5, which is our base. We're going to write down 5. We're going to go to 3. The exponent is always on the right when it's in log form. So 5 to the third power. Go around to your equal sign, write your equal sign. And then we're going to move around to x plus 3, and that's what goes on the right. So we've made it all the way around our log. We're going to simplify each side and solve. 5 to the third power, 5 times 5 times 5 is 125. And then on the right-hand side, you still have x plus 3. Subtract 3 from both sides. So on the right-hand side, all we have left is x. On the left-hand side, 125 minus 3 is 122. Okay, the next question is, which of the following functions represents an exponential decay with a 17% rate of change, where a represents the initial value and x represents the time in years? Highlight the important information. This is an exponential decay problem, so we're going to use the exponential decay function. We have a rate of 17%, and a is going to represent the initial value. X is going to represent the time in years. All right, time is always going to be our exponent. Okay, our exponent is going to be time, and we're using x to represent time. So all of these, except the last one, have x as an exponent. Okay, our rate, we're going to start with our initial amount. So a is going to be our initial amount. That goes here, here, and here. All right, 17% is our rate. We're going to take that 17% and we're going to change it to a decimal by moving the decimal 2 places to the left. So it's 0.17. All right, when we're talking about decay, we're going to subtract that percent from 1. When we're talking about growth, we'll add that to 1. So 1 minus 0.17 is 0.83. So it's not going to be 0.17. We've got to subtract that from 1. Okay, this is adding 0.17 to 1. So B is the equation, the way that we set this up with that information. All right, the next question gives you the values for the function f of x in a table. This is a horizontal table, the one that we looked at as we worked in class, vertical table with your x's here and your y's here. We have the same thing here, but it's a horizontal table. And remember, y is also called f of x. All right, which statement proves that f of x is an exponential function? All right, don't just pick an answer that you think is correct. Pick the best answer. All of the values of f of x are even numbers. So let's look at f of x. Those numbers are all even. 2, 8, 32, 128, 5, 12. and 2048. But that's not what makes this an exponential function. Just because they're even doesn't make that an exponential function. All of the values of x are multiples of 2. So I'm going to look at x. Now all of the values of x are not multiples of 2. 1 is not a multiple of 2. 2 is a multiple of 2. 3 is not a multiple of 2. 4 is. But 5 isn't. Every other number is a multiple of 2. So this isn't even a true statement. Okay, C, the function f of x grows. So we're going to look at f of x to see if it's growing. So it's starting at 2, goes to 8, gets bigger each time. 32, 128, 512, and 2048. Okay, so that's true. But it's growing by equal factors over equal intervals. So if we look at x, the intervals are equal. We're going up 1 each time. We're just adding 1 each time. So those intervals are equal. So let's see, how do we get from 2 to 8? Okay, a factor means multiply. So what number are we multiplying 2 by to get to 8? We're multiplying by 4. Okay, 2 times 4 is 8. Is 8 times 4 32? Yes. And is 32 times 4 128? Yes. And is 128 times 4 512? The answer is yes. And is 512 times 4 2048? So the factor is 4. That's our growth factor. Okay, so C is the correct answer. Let's look at D just to make sure. The function f of x grows by equal differences over equal intervals. Okay, it's different. It's equal factors, not differences. Differences indicate subtraction. So that's not the correct answer. The answer is C. All right, the next question, which equation represents the graph? All right, so we're going to look at y equals 3x squared. What I would do if I were you is I would go ahead and graph those and see which one has a y-intercept of 5, okay, and also has an asymptote, has a horizontal asymptote at y equals, looks like y equals 4. Okay, so let's just graph each of those. Y equals 3x squared. This, just looking at that, is a quadratic equation. We're squaring. We have an x squared. We have a quadratic term. So that's not going to be our function. Okay, let's look at the next one. Graph the next one. Y equals 3 to the x. All right, that doesn't look like a match. 3 to the 0 power. When x is 0, y is 1. Okay, so it looks like it's got a, it looks similar, but it looks like it's got a shift up. It's going up 1, 2, 3, 4. It's going up 4 in that direction. To indicate a shift of 4 in the vertical direction, we add 4. So this C should be our answer. Let's graph that. If we shift up 5, starting here at 0, 1, and we go up 5, 1, 2, 3, 4, 5, we're going to end up here. Okay. All right, that does look like C is a match. And then let's just graph D just to be sure. Yep, D does shift up 1 more. So graph each of these and find a match. The answer is C. The next question, which of the following function is an exponential decay function? All right, decay means that we're going to be multiplying by a number that's between 0 and 1. Okay, it's going to be less than 1, greater than 0. It means it's not negative. All right, this is our initial amount. Our growth factor here is greater than 1. So this is a growth. It's going to go up. All right, this Here's my growth factor right here. But that's greater than 1. This one's greater than 1. This growth factor, whatever we're raising to a power, find that exponent. Here's the exponent. What we're raising to a power needs to be less than 1. That's going to show decay. So D is our decay function. All of these other numbers that we're raising to the power of x are larger than 1. Okay, I'm highlighting decay. First one, that's growth because 1.025 is greater than 1. 3 is greater than 1. 4 is greater than 1. But 85 hundredths is decay because that's less than 1. Right, the parent function of an exponential equation is defined as f of x equals 3 over 5 to the x. Which function would translate the parent function vertically? So we're going to take that parent function. Vertically means it's going to be going up and down. If you remember your function rules, that number needs to be outside, away from the x, not attached to the x. Okay? And anything that we're adding or subtracting over here, adding goes up, subtracting goes down. Okay, so which one shows where we're adding something? I think it's going to be A. Okay, this one right here is going to be a horizontal shift, so that's going to go left or right. And it's going to appear the opposite of plus 7. It's going to go to the left 7. Okay, so the answer is A. All right, looking at B, we do have a reflection because we've got a negative sign right here. We also have a reflection or a flip right here. And again, like I said, a horizontal translation, 7 units to the left. And we only have a stretch here, stretch of 6 in the direction of the y-axis. All right, the next question. The half-life of a certain radioactive material is 20 days. An initial amount of the material has a mass of 150 kilograms. Find the amount of radioactive material that remains after 30 days. Round your answer to the nearest thousandth. So we're going to highlight the important information. This is a half-life problem. We're going to use the half-life formula. All right, our half-life is 20 days. Our initial amount is 150, and our time is 30 days. So let's put that in our formula. Here's our formula. A is the total amount, P is the initial amount, and then we're raising 1/2. T is the total time, H is the half-life. All right, so we're going to replace P with 150, time is 30, and the half-life is 20. Okay, put that into Desmos. Put this part into your calculator, this part of the expression, and solve. Okay, you get 53.0333. This is the tenths place, hundredths place, thousandths place. So the answer is 53 and 33,000th kilograms remain after 30 days. Okay, we're asked to write the following exponential equation in logarithmic form. All right, we're going to use that same hamburger helper method. Start with log. Our base is going to go down a little bit below the line. The base is what we're always raising to a power. So our base is 121. Okay, then we're going to put our answer right here. Our answer is 11. So we start with 121, go around here, pick up 11. Then we're going to go around and get our equal sign, equal. Okay, and then the exponent, this doesn't really look raised, but this should be 121 to the 1/2 power. It's just hard to type that in that way. So the exponent goes to the right. And then we have made it all the way around. Okay, so log base 121, 11 equals 1/2. We want to write the following log equation in exponential form. Again, we're going to start on this side with 5. We're going to go around, pick up the exponent. In log form, this is always the exponent on the right-hand side. So 5 to the negative 3. Go around and pick up your equal, and then finally 1 over 125. Okay, we've made it all the way around. All right, this makes sense. A negative exponent, 5 to the 3rd power is 5 times 5 is 25, times another 5 is 125. But it's a negative 3, so that's going to put that on the bottom of that fraction bar. And that looks like that is correct. 5 to the negative 3 is 125. We want to evaluate this logarithm. So you can just basically put this into Desmos. Putting it in your calculator, you'll see that the log 9 of 1 over 729 equals negative 3. Now we're asked to evaluate the logarithm log of 0.0001. Okay, we're going to do the same thing. Put it in your calculator, and you'll get negative 4. The next question, we're asked to solve the exponential equation 1 over 16 equals 64 to the 2x plus 1. All right, let me get my pen. We're going to break down 16 into, let's see, 16 is a perfect square, so I'm going to write it as 4 squared. Okay. Now 64, I'm hoping that I can find the same base. Is 64 factors, can we factor 4 and just use 4 to divide into 64? 4 goes into 64. See, 4 goes into 6 one time, and 4 goes into 24. 6 times. All right, keep dividing. 4 goes into 16 4 times. So yes, 64 is 4 to the 3rd. Okay, now this is 4 to the 3rd to the 2x plus 1. Now let me look back over here on the left. Okay, that 4 squared is under the fraction bar, so I need to make this a negative 2 to put it on top. So 1 over 16 is 4 to the negative 2, and 64 is 4 cubed, but it's raised to the 2x plus 1. All right, so multiply power to a power. You're going to multiply 3 times 2x. So this is 4 to the 6x plus 3 times 1 is 3. All right, now that we have the same base, we can set our exponents equal. So let's just mark those out and set negative 2 equal 6x plus 3. So you have an equation now that you can solve. All right, I'm going to start by subtracting 3 from both sides. I don't know why I drew that bar. Forget that I drew that. I should have drawn it underneath. Negative 2 plus negative 3 is negative 5. Equal 3 minus 3 is 0 equals 6x. Divide both sides by 6. X is equal to negative 5, 6. 6 over 6 cancels, so x is equal to negative 5 over 6. All right, on this next problem, we're asked to solve the exponential equation 27 to the 2x plus 3 equals 15. When you have a variable in the exponent, in order to undo that exponent, we need to go to logs. So we need to take the log of both sides. Okay, if I take the log of 27 to the 2x plus 3, once I've taken the log, that's going to come out to the front. So this is going to come out to the front, 2x plus 3 times log 27 equals, remember we have to take the log of both sides, so this is the log of 15. And remember that we're solving for x. We're multiplying this by the log of 27, so let's divide both sides by the log of 27. Divide the right-hand side by the log of 27. This is going to cancel. Okay, so we have 2x plus 3 equals log of 15 over log of 27. I'm going to subtract 3 from both sides. It's going to cancel over here. And then finally, I'm going to divide both sides by 2. Divide by 2, that's going to cancel the 2 out here. So all this we had over here, if you divide by 2, we should have our solution. So x is going to equal to log of 15 divided by the log of 27. Put parentheses around that in decimals. Subtract 3, all of that in parentheses, and then divide it by 2. All right, there's one thing that we need to note right here. Okay, when we put this in our calculator, we have a negative log. Having a negative log, think about exponents. We can't have a negative exponent. If we have a negative, if we're trying to take the square root of a negative number, we get an imaginary number. Logs are the inverse of radicals. So this is going to be no solution here. If we have a negative log, there's no solution. Right now we're asked to solve the following equation. Log of 10k minus 15 equals log of 9k minus 10. This is a common log. It's log base 10. You don't see the base. We can go ahead and mark out the log. We have base 10. This is a common log. So we're going to cross out log on both sides and set up the equation 10k minus 15 equals 9k minus 10. And we're going to work on solving that. So I'm going to start by subtracting 9k from both sides to move the variable to the left. 10k minus 9k is 1k. Bring down the 15, the negative 15. Bring down the equal. 9k minus 9k is 0. And then bring down the negative 10. Okay, finally, add 15 to both sides. Bring down the k. K is equal to positive 5. The next problem is a word problem. Susie invests some money in a savings account with an interest rate of 5.25% compounded continuously. If the account has $1,774.98, after 10 years, what was her original investment? All right, we're going to use the A equals P times E to the RT because it says continuously. So let's identify what R is. R is our rate. It's 5.25%, so we're going to move that decimal 2 places to the left to get 0.0525. A is our amount, our total amount after 10 years. that's given to us is $1,774.98. We want to know the original investment, so we're trying to find P. All right, you'll see that we have time. Time is 10. 10 times the rate is going to be our exponent. All right, because this is continuous, we're going to be using this formula. A stands for the total amount, is equal to P. P is our initial amount, times E. E is Euler's number, raised to the R times T. That's the rate times time. Let's pick out what we have. We've got 5.25%, so we're going to move that decimal 2 places to the left and change it to 0.0525. All right, our total amount is $1,774.98. Okay, I didn't highlight the 10 years. I should have. That's our time. T is 10. Okay, we want to know the original investment, so we want to know P. We don't know P. All right, putting that into our formula, we get our total amount is $1,774.98. That's equal to P times E to the 0.0525 times 10. Multiplying the 0.525 times 10 moves that decimal 1 place to the left. So if you want to, you can go ahead and move that over. Just take that 10 out. I didn't. I'm just going to divide both sides by, because I'm solving for P, E to the 0.0525 times 10. So divide on both sides by that, and then you'll have P. So put this into your calculator to get your answer. And you can see down here what I got when I put this into decimals. I got $1,049.99. Rounding that up to the nearest dollar is $1,050. All right, the next question. Suppose you want to invest $2,500 into a savings account that pays 3.5% interest compounded monthly. Left untouched, how many years would it take your money to double? If you're setting up this problem to solve, what is P, what is R, and what is N? All right, so first let's identify, get my pen, okay, what P is. P is the initial amount. Okay, the initial amount that we start with is $2,500. What is R? Okay, it gives us R as percent. Now we need to move the decimal 2 places, 2 places to the left. So that decimal is going to go here, and you need to fill in a 0 here. I usually put a 0 in the front of my decimal, 0.035. And then what is our N? N is the number of times that we compound. We'll compound in a year. So we're compounding monthly. So N is equal to 12. There are 12 months in a year. All right, for this question, it says, suppose you invest $2,500 into a savings account that pays 3.6% interest compounded monthly. Left untouched, how many years would it take your money to double? So this is very much like the last problem. We just changed the percentage amount. So P is equal to 2,500, R is equal to 0.036, and N, the number of times that we're compounding, is 12. The total amount, if we're going to double $2,500, is $5,000. All right, setting that up. All right, we're going to have $5,000, our total amount, equals $2,500, the initial amount, times 1 plus the 0.36 divided by N over 12 to the N times T. We don't know T. We have to leave that variable. And then I divided both sides by 2,500, so this would cancel. $5,000 divided by $2,500 is 2. All right, I went ahead and put in Desmos 0.36 divided by 12. That's 0.003. We're going to be adding that to 1. So I'm going to simplify this. 1 plus 0.003 is 1.003. Okay. All right, if I look at the left-hand side, 5,000 divided by $2,500 is 2. Bring down the equal. The 2,500 divided by 2,500 is 1, so that's going to cancel. And then we're left with 1.003 to the 12t. All right, if you divide, I'm sorry, not divide. If you take the log of both sides, we'll have the log of 2 equals the 12t. When you take the log of 1.003 to the 12t, you've got log of 1.003, and that 12t comes out to the front. All right, now we're trying to isolate the t, so we're going to divide. I'm running out of room here, so let me talk you through this. We're going to divide both sides by 12 log 1.003. All right, you can see that I put this into Desmos. On the left-hand side, we've got log 2, and we're going to divide by 12 log 1.003. Okay, we'll get 19.2829550625. Okay, rounding that off is approximately 19 years. All right, looking at this graph, what is the domain and the range of function f of x equals log x minus 7 minus 2? Now, this is the type of question that you'll get on your test. We want to write our answer in interval notation. So the easiest way to do this for me is to go ahead and put this into Desmos, and you can see the graph. Because this is a log, it's the inverse of an exponential function. Okay, so now we're looking at the domain. The domain is going to be your x values. There's an asymptote right here. Okay, it's going to get very close to, this is 5, 6, 7, to x equals 7. So x is going to start at 7, and then it goes to infinity. Okay, so this is your domain, and your range can be anything. Your range is your y values. So negative infinity to positive infinity. It's going up slow, but it will go up to infinity. Okay, so graph it and then put it in interval notation. All right, for this function, f of x equals log base 3, x minus 2 plus 1. I put this in my calculator, and I got this graph. All right, so we want the equation for the vertical asymptote. The asymptote starts at x equals 0, okay, but you can see we're moving over horizontally. We're moving to the right 2. Okay, so our asymptote is going to be here at x equals 2. All right, the next question, we have a bacteria doubling in population every 6.5 hours. Given that there were 10 bacteria to start with, what will be the population after 15 hours? Round to the nearest 10th. All right, I'm going to use this formula because we are, let me see here, we are doubling. So this is the double time formula. A equals P, our initial amount. 2 is our base. T is our total time. D is our double time. All right, so A equals 10 is our initial amount. We're going to put that in place of P. Okay, and then T is 15, and our double time is 6.5. So put this into Desmos in your calculator. Okay, and you'll get 49.50905142122. Rounding to the nearest tenth is 49.5. All right, we have a function, f of x equals 12x plus 3. It has a domain of negative infinity to infinity. So it's going on the x-axis. We have nothing that we're eliminating. It can go from negative infinity to positive infinity. But the range is where it starts on the y-axis. We have an asymptote at 3 because we see we shifted it up 3. So it goes from 3 to positive infinity. Okay, we want the domain and range of the inverse of f of x. So that's going to be the log. All right, so basically all we do is swap the domain and the range. So now if we write the inverse of this function, which would be the log, the domain is going to be 3. Let me get my pointer. Okay, this is our range. Now it's going to become our domain. And our domain is going to become our range. Okay, so the inverse of this function, again, the domain is going to become 3 to infinity, and the range is negative infinity to positive infinity. All right, what is 2 to the 12 equal 4,096 written in logarithmic form? Okay, we're going to use our hamburger helper hands. Oops, let me go back. This is the last one. Okay, use our hamburger helper hands. So we write log. Okay, we're going to start with the base. The base is what we're raising to a power. We're going to write that down a little bit. Okay, the next thing that comes is our answer, 4,096. And then equal, and then what we always have on the right on our log function is our exponent. Okay, so 2, log base 2, 4,096 equal 12. Let me get back around to our log. All right, that's it.